Thank you for all for being here for my Soutenance d'habilitation à diriger des recherches, which means accreditation diploma for supervising research entitled Designing Serious Games, Mobile Learning, and Extended Reality Applications for and with Teachers. My name is Iza Marfisi-SCHOTTMAN, and I work at LUM. I've been here for 10 years now. So first, before I get started, I wanted to introduce to you the field in which I do my research and more precisely the domains, the specific domains in which I was interested in and to which I've contributed during these 10 last years. Now, as you can see, the field in which I do research is called technology-enhanced learning, and it is by essence multidisciplinary because it uses learning methods and theories from humanities and social sciences, but it also builds on models and technological advances from computer science. So I'll mostly focus on the contributions for computer science because that's my field, but bear in mind that all the projects that I've led were done in collaboration with colleagues in humanities and social sciences. Now you see I've pictured this technology-enhanced learning field as a tree in which there are different branches, which are subdomains, and I also pictured leaves at the end of these branches, well, on these branches, and this is the symbolism that I will be using to represent my projects. Now, the first research branch that I'm interested in is serious games. This is a branch that I've been interested in since my PhD. So serious games are at the intersection between learning objects, learning tools, games because they use game mechanics, and also simulations. Even though the simulation doesn't necessarily have to be visible, you need to have some kind of model that's related to the learning objectives. I'll show you this example of game. This is very well known. It's called the Logo Turtle, and it's aimed to help kids learn the basics of computer programming. So they program, and as you can see, it's very small, but you have a little turtle that does the code and that draws geometric shapes. However, serious games are not just for children and not just for computer programming. They can be used in all types of fields for any age, and as a matter of fact, a lot of serious games actually target nurse practitioners or doctors to deal with complicated emergency situations, for example. Now, the challenges of serious games, there's several. First of all, there's the design. They're difficult to design because it's not that easy to find the right game mechanics for your learning objectives. We don't have a clear set of rules yet. And once you've found the right game mechanics, if you found the right game mechanics, it's also hard to merge them or to mix them into the learning activities effectively. Another challenge is related to the cost. It's very expensive to create serious games simply because you need a large team with a teacher, you need a game designer, game developers, you need graphic designers, all this team that is very expensive. Basically, the entire team that you need to create a video game, even though your potential return on investment is not very high, because the serious game that you're designing is targeted to a few people who are working on the learning objectives in your serious game. One of the last challenges is to democratize these tools in schools because they're still very rarely used, even though research shows that they have great potential for motivation, for increasing motivation and increasing the learning outcome. The second research branch I'm interested in is called mobile learning. Basically, it's learning with your smartphone that everyone has in their pocket now. Here, for example, you see students learning about how to identify a tree, and what better way to do this than outside next to real trees. It's the same if you're learning history. The best way to learn about history is to be on an archaeological site, or visiting a historical museum or something like that. Now here, once again, we have several challenges. It's not easy to design these tools because it's not enough just to provide all the information on the smartphone. The activities have to be redesigned so that they foster real, authentic, situated learning. We want the students to look around them, to observe and to use the information they've observed to to learn something new. Another issue here is the use in schools that usually only have old tablets with very limited technical functionalities, and therefore most of the learning games that you see in the literature do not work on these tablets. Which leads us to a third challenge, which is once again, democratizing these tools that are very rarely used in schools, even though they could be very useful. My last research object is related to the field of the subfield of human-computer interactions for learning. To be more precise, I only focused on a subdomain of human-computer interactions, which is extended reality. This covers mixed reality and tangible interactions. These are interesting for learning because you have all the potential, all the benefits of digital tools, but you also keep the manipulation of objects, which is very important for learning, especially with kids. Augmented reality also allows you to show digital information on real objects, so this is also interesting for learning. And virtual reality, such as this example here, where you see a learner wear a virtual headset and he's completely immersed in a virtual environment in which he's talking with an embodied virtual conversational agent. And this can be also very useful for recreating situations that are emotional, for example, or authentic or realistic to train on different things. Here, once again, we have several challenges. The first is designing these tools and finding the right innovative human-computer interactions for the objectives that we have. The second is the development, because it's very hard to find specialists that can work with these new technologies. There are very few of them, and they're often in companies and have a very decent salary. And the third is therefore the fact that we would like to democratize these tools that are very rarely used in schools, even though they have all these great potentials for learning. Now, in the rest of this presentation, I'll be calling these human-computer interactions and not extended reality, because I wanted to show the fact that my research is not technology-centered. My objective, as you'll see, is to work with teachers to identify the best game mechanics, the best HCI that could work for their problem. And so it so happens that I've only so far worked with HCI that was extended reality, but in the future I might be working with other forms of human-computer interactions. So as you may have noticed, serious games, mobile learning, and innovative HCI for teaching all have common challenges. The first is the fact that they're all difficult to design because they implicate different actors, and we don't have a clear set of rules to design them. And so my first research objective is therefore to provide methods, models, and tools to help all these necessary actors design effective technology-enhanced learning systems. The other challenges are related to the fact that these tools are difficult to produce, to develop, and they're also not used in schools because either they don't have the right material or they're just not, they can't be used correctly, or it's difficult to make them accepted in schools. For this reason, my second research objective is to provide adaptable models and authoring tools to facilitate the development of TEL systems by teachers themselves with the resources and the equipment that they already have in schools. Now let's start with the first research objective, which, as you remember, is methods, models, and tools for facilitating the design of effective technology-enhanced learning. Now, to reach this objective, I've led several projects. 3 exploratory projects. The objective of these projects was to measure the potential of mobile learning, HCI, and human-computer interactions for a specific type of domain or a specific type of learning objective and context. So we have 3 projects. The Tigris project, here the objective was to measure the impact of virtual reality to help professionals deal with complicated emotional situations. This project has 2 originalities. The fact that the entire content of the virtual reality simulation was provided by the trainees themselves, who had analyzed and identified real problematic situations that they had encountered in their professional life. And the second originality is the fact that the reactions of the avatar, of the embodied virtual conversational agent, are all triggered in real time by the trainees, by other trainees, so that they can create a custom, tailor-made situation and experience for the person who's wearing the virtual headset, the virtual reality headset. The second project is called Smart Fractions, and here the objective is to explore the potential of mixed reality for learning fractions. And the third project is called Turtle Tablet, and here the objective was to test if the use of tangible objects, so you see that the kids are holding one tangible object each, the use of these objects would change the way that they collaborated while they were learning the basics of computer science, computer programming. I'll show you how these tangible objects work. So the students can slide them down the screen, as you can see, and each time they do an action, they're actually executing the code that's on the left. So you can see that this is clearly inspired by the logo, turtle logo that I showed you before. So in addition to these 3 exploratory projects, I've also been leading a professional training course for 7 years now. And thanks to this, we were able to identify a good method to help teachers create their own serious games themselves with the resources that they have. The last project was led with my second PhD student, was to create a serious game catalog that allows you to find serious games that are out there. There are actually 800 for the time being. And what's interesting about this catalog is that it updates automatically. It goes and fetches new serious games that appear on internet. And so here the objective is to help teachers find serious games that meet their needs, or find serious games that they could use as inspiration to create new serious games. This can also be used by researchers in serious games, of course. So, of course, I won't have time to present everything because I only have 45 minutes. So I'll concentrate on the Smart Fractions project because it's very typical of the projects that I lead. And I'll also talk about ludification. So before I get started with the Smart Fractions project, I wanted to talk to you about the design-based research method. It's a design method that's commonly used in the field of technology-enhanced learning, and basically it shows that to create an effective technology-enhanced learning system, you need to go through several iterations of 4 phases: reflecting, co-designing with teachers, this is very important, testing the tools that you've just designed in the classrooms in real context, evaluating them, and going around and around until you manage to have a tool that everyone is happy with, or you run out of time or money. So I'll use this example to show the Smart Fractions project. So the first phase is the reflection phase. And as you can see here, we worked with math didacticians and math teachers to identify several challenges. The first is the fact that learning fractions is complicated for kids. It's actually one of the most complicated topics that they have to learn in middle school. One of the things that makes fractions particularly complicated to understand is the fact that they're represented with different forms of representation. Here you see fractions represented as portions of a geometrical object, portions of an object or of a geometrical shape. And here you see fractions on a number line. And students have a very hard time making the link between these two representations. We also identified that some students suffer from what we call math anxiety. This is also identified in literature, especially young women. And the teachers also told us that one of the problems that they have was the fact that exercises in fractions, currently a lot of the students ask questions constantly, so they're not very autonomous. So this is something we also wanted to work on. After this reflection phase, we went to a co-design phase, during which we worked with the teachers and the math didacticians, and for which we also did a state of the art to find what existed out there. One of the things we found with the state of the art is that mixed reality could be interesting in our case because it was used in other similar cases and had given good results. And we thought that for our case it could be particularly interesting because mixed reality is capable of recognizing a picture, for example, and showing in real time other information on top. So for our case, I'll show you here what we did. I'm sorry for the sound, I don't know if you can hear it. You saw that the girl actually used a game piece, which is one form of representation of fraction because it's a portion of a geometrical shape. And when she put it down in the cauldron, I'm just going to put it back. When she put it down in the cauldron, look what happens. There's 1/2 that shows up on the piece, which is another form of representation. And most importantly, you can also see it here on the number line. It's not in the middle because the number line goes from 0 to 2, just in case you're wondering. So we thought that this could be interesting for our case. I'll stop the video. So we worked on different types of mixed reality activities that do the relation between 2 or 3 forms of representations of fractions. And we went for a test phase with 10 students to see if this could be of interest for them and if it seemed to be something that could be potentially interesting. The results were quite positive because the students thought that this was very interesting. They saw the interest and it seemed to really help them make the link between the two forms of representation. We also asked them which type of games they were into, the game characters, or the game storyline that they would prefer. We then went back for a second phase. So here we're in the second phase of the second iteration cycle. And we decided, in light of the good first evaluation that we had, that we would continue the project and develop a game. This is when we worked so we're in the co-design phase again now. This is when we worked on the game scenario with a professional story writer. We also worked on the game levels with teachers based on the activities that we had identified before. And we worked on the game material. We tested this first version of the game, complete version of the game, with 25 students. And to be honest, we had quite a few problems. We observed that the learners needed much more help at certain specific activities. We also saw that the game material was much too complex. They kept on losing pieces. They also had too many sheets of paper. And we also had lots of technical problems. This is when we came back to a reflection phase for a third iteration cycle, where we decided to continue the project, even though we had a few problems, but to improve it in different ways. And this is also when we implicated 2 new pilot teachers. And this was very interesting because these pilot teachers had new insight on how we could improve the game. So we then continued on a co-design phase with these new pilot teachers, during which we added built-in help that's provided by Echo, the little character that you see up here, friendly character. And we also built simple and sturdy game material. We then tested this final version of the game with 228 students, and we used videos, pre-tests, post-tests, etc., questionnaires, semi-directed interviews with the teachers and with the students. And oh, I forgot to tell you, we did 2 experiments. We did a short-term experiment in which we compared a group of students that was using the game and another one that was going to a classic course, and we switched them after. And we also did a long-term experiment on several months where we left the game material to the teachers to see if they would use it and how they would use it. So we were able to analyze all this. I'm just going to turn off the sound. So we were able to analyze these videos, analyze the usage tracks, do statistics, comparative statistics on the pre-test, post-test, and these are the results. So we managed to identify that the learners progressed with the game as well as a classic course. Here you can see pre-test and post-test. They actually progressed a little bit more in the classic course, but it's not statistically significant. We also saw that the game helped reduce math anxiety as much as a classic course. However, we did see that the game in mixed reality helped a great deal for the autonomy of the students. So they asked much less questions, and it also provided a much more enjoyable experience than a classic course. So in terms of contributions, scientific contributions, these items, how can I say, these results can be translated into design principles that were then published and that can be used by other researchers that are working in the same domain. So these are the real contributions here in terms of for the scientific community. Now, you remember this design-based research method? Well, the fact that we led several projects, exploratory projects with this method, actually allowed us to be more precise and identify specific phases and specific productions that needed to be done at these times, because it's actually very vague. You don't really know how to use it exactly. For example, in the Smart Fractions project, we realized that it was important to do not one but several design sessions, and that it was extremely important to come to these design sessions with working prototypes. It wasn't enough just to talk about mixed reality or even show videos of mixed reality. The teachers had to manipulate the object, they had to manipulate the technology to figure out a good way to use it, a way that was meaningful for their learning objectives. We also saw, for example, that it was important to have a pre-experiment meeting, which seems logical, but it was very important to do this way in advance to make sure that the teachers had all the material they needed, all the information, that they could then pass it on to the students so that their parents would sign it much earlier than before the experimentation. One other item that we saw was the fact that it was very interesting to gradually implicate new actors, because these new actors, had fresh insight on how the game could be improved. And this is something that we were just not capable of doing anymore because we had been in the project for several months, and we didn't see anything anymore, basically. So these are a few add-ons that we did for the Smart Fractions projects, but with all the other projects, this is what the final result looks like. So as you can see, we've identified productions and work sessions and who should be working when together. So this is also a contribution to the scientific community that we call the practical implementation for design-based research. Now, I also wanted to talk to you about Ludifique Action, which is a professional training course that I've been giving for 7 years now. And as you can see here, this professional training course helps teachers design their own serious games, and they can be digital, non-digital, hybrid, whatever, What's important for you to understand is that I'm not the one who does the work. I'm just there to accompany them, and it's the teachers who design and produce the serious game themselves and use it in class. Now, for political and technical reasons, I gave this training session at different institutions, different universities, and they all had different constraints, which forced me to change the way that I was giving this training session, this training course. Sometimes it was longer, sometimes there was more or less staff, sometimes we had a fab lab, sometimes not, etc. And so this was actually really frustrating at first, but it was actually also very helpful because we were able to compare these modulations, these fluctuations of how we organize the course to identify the one that was the most effective in terms of serious game design. So we were able to identify the best, or one of the method that worked the best from those that I tried in any case. So it's a 5-month training session for which you have specific sessions, specific documents, information, and activities that need to be done at a given time. We also identified the 10 guidelines to help teachers get started, which we call the 10 commandments of the serious game Padawan. Now, something that was really interesting in this project is that we were able to witness, a phenomenon that was quite interesting. It was the fact that the teachers who had managed to create their serious games were very enthusiastic about them and were very happy to use them in class. And this just changed the whole dynamic, because when they went in class, they were happy to be there. They knew how to use this tool, their serious game that they had designed, and it just changed everything. It just made the whole experience, the learning experience, much better. Even though sometimes the games that they had designed weren't great. So what I mean is that it's because it was their serious game and they knew how to use it correctly that it created this good experience, and not so much because the serious game was good quality. Now, this phenomenon is not new. It's something that's been studied by researchers for a long time. Rabardel called it instrumentalization, if I remember correctly. And basically, this means that it's important to make the tool yours. That's how you can feel comfortable using it. And it's the same. I mean, this makes sense because I don't know if you've already tried presenting a PowerPoint presentation that was already all prepared for you. Well, if you really want to be at ease presenting it, the first thing you're going to do is change the content, or at least change the order of the slides. I don't know. I mean, you need to feel, if you want to feel at ease presenting it, you need to modify it. You need to make it your own. Well, it's the same for teachers. If you provide them with a technology-enhanced tool that they cannot modify, well, there's very little chance that they will feel at ease using it and that they will use it in their class. Which brings us to my second research objective, which is to provide adaptable models and authoring tools to help the teachers themselves create their serious games with their content and use them in their class. So just before I continue, I wanted to make sure that you've understood what an authoring tool is. I don't know if you've already used WordPress. It's a very simple editor that allows you to create a website, and it's very simple. You just add text, you copy and paste some pictures, you click on a button, and whoop, it creates a functional computer application. So here it's a website that works on any type of device. It's the same thing for technology-enhanced learning authoring tools, but we're interested in teachers. We want teachers to be who are not computer scientists to have a simple editor to create their technology-enhanced learning tools that can work on the devices that they have in their schools, so mainly computers and old tablets. Authoring tools have several advantages. First, they cover a wide range of needs. Unlike the projects that I showed before in the first part, because we designed these with maybe 2, 3, or 4 pilot teachers maximum. So apart from those teachers, I'm not sure it really corresponds to the needs of other teachers. It also allows teachers to do collaborative design, which can be very interesting to create good quality technology-enhanced learning tools. The TEL systems that are produced with these authoring tools are also ownable, meaning that the teachers, since they put their content in it, they feel at ease using it because it's their own. They're reusable because if the teacher wants to change something for the next year because, I don't know, the curriculum has changed or the profile of their students has changed, no problem. They can go back into the authoring tool, change the items, change the elements, and recreate the TEL tool. And they're also low cost because teachers do not need to hire game designers or game developers that are very expensive, or professional developers in specific augmented reality or whatever technologies, because all of their knowledge is embedded into the authoring tool. However, authoring tools do have design challenges. Basically, there's two. It's complicated to design an authoring tool that is at the same time powerful, meaning that it covers a wide range of needs with many functionalities, but that is also very easy to use. This makes sense because the more functionalities you add, the better suited it can be to a lot of people, but the interface is going to become very complicated and therefore not easy to use. So this is a very hard balancing to do, and this is one of the main challenges. The second challenge is related to the fact that teachers tend to use technology-enhanced learning to simply recreate the learning paradigm that they currently use. And this is a pity because, as you saw before, mobile learning, serious games, and innovative human-computer interactions, these are all new ways of teaching that can have a potential, but teachers don't know about this potential, and naturally they're not going to go towards it. So this is the second challenge, is for authoring tools to help teachers, to encourage teachers to try these new ways of teaching. Now, for this second learning research objective, I've participated in 3 projects on mobile learning games. The first project, Gem Inventor, is my integration project for LUM. That was 10 years ago, and we got financing for my first PhD student. And his PhD was, the objective of his PhD was to design an authoring tool, so simple editor, that allows teachers to create mobile applications for their field trips. I then participated in the Rêverie project, which was quite similar, but here we were focused on learning about recognizing plants that surround us. So we actually used the same model that we had designed for the Gem Inventor project, but we redesigned another authoring tool focused on helping teachers co-design, because this was an important part of the project. And we also added specific functionalities for tree recognition. The last project, which is the project that I'm currently leading, Si tu learn, is here the objective is a bit broader because we're not only interested in teachers, but we also work with mediators who work in museums and tourist offices. So here what we did was basically we built on our experience with the 2 preceding projects. We used the same model that was enhanced and modified, improved, and we also redesigned an interface for the authoring tool that has the best functionalities of both of the projects above. In parallel, I've also been leading another project called Mix Up, and here the objective is help teachers create their mixed reality activities for learning. So I won't have time to present this project in detail, but it's very interesting, so don't hesitate to go see the website, Mix Up. I wanted to show you, so basically it's a very simple editor, and it allows teachers to augment the learning material that they currently use. So here, for example, the teacher augmented a book, and I don't know if you can see, but one of the kid is holding the tablet, and you can see ciseaux, which is the word for scissors, that appears on the image of the scissor. And the other kid, so it's a collaborative activity, the other kid has to find the right little word in among other words, and there's tricky words in there. So this is an example of an activity that was designed for preschoolers, but this project was actually designed with 19 pilot teachers, some from middle school, primary school, preschool, middle school, high school, and professional learning. So we have a very large variety of activities that can be created with this mixed-up authoring tool. Now, as I said, I won't be able to present everything, so I'm just going to focus on C2Learn because it's the most mature of these projects. So this is what the interface of C2Learn looks like, the authoring tool. So as you can see here, the teacher is creating his scenario. The first thing he needs to do is edit a map on which he's going to identify points of interest in which he wants the students to go to physically. The teacher can also add activity information sheets that are provided to the students when they get on site, and activities that need to be done on site too. So these activities can be questions, but also taking samples, meaning that he's going to ask students to take photos, take notes, take audio recordings of what they see around them. And all this information can be accessed after the field trip to be used in class during the debriefing session. Now, in terms of contribution, this authoring tool has several. It has, first of all, it proposes a nested design approach, meaning that the interface is very simple at first. It only shows the basic functionalities, but then hidden in the options, the teachers can find all the functionalities they need to create a custom experience that they're looking for their field trip. This tool also provides a set of templates and built-in help, and it also has a co-design support because teachers can share the whole scenario or just parts of the scenario. Now the tool is built on a model that has all the elements that I was just talking about before, all the concepts. So you have a mobile learning game, which is composed of situated game units that are done on points of interest. You also have activities that can be done at these points of interest. And this model is highly adaptable. So this is a contribution in the sense that teachers can use this to create different types of field trips, different types of outings. They can create treasure hunts that are perfectly adapted for field trips, educational field trips. They can create activity hubs that are perfectly adapted to what we find in museums. And they can create interactive walks, which are perfect to discover a city or discover an archaeological site, for example. We also have a model that's specifically done for collaboration during a field trip. It's a collaborative field trip model. This model is also extendable. For example, for the Rêverie project focused on identifying trees, we created a new type of activity on this topic. It's also pre-configured with game mechanics. You see all the blue zones? Actually, those are the only ones that need to be filled in by the teachers. All the other zones come with pre-configured values, which makes it much easier to create your first scenario. It's much faster. And it also encourages teachers to use game mechanics that they probably wouldn't have used before because they're there by default. They can always take them off after if they don't want them. This model is also transformable, so I didn't show you, but there's a bigger model beneath this model that allows to transform all the information that's provided by the teacher into a functional mobile application. Now, do you remember this design-based research method to which we already added quite a few items? Well, after leading two research projects on authoring tools for technology-enhanced learning systems, which are a specific type of research project in technology-enhanced learning, we were able to identify even more guidelines and design principles for this type of project. For example, we identified the fact that it was very important to implicate a reasonable number of pilot teachers from the beginning of the project, because the objective of an authoring tool is to be accepted by a large variety of teachers. So you need to have that variety of teachers, a representative variety of those teachers in you with the project from the beginning. We also identified the fact that it was very interesting to work with a teacher training institution. This is what we did with Mixup, and it was very interesting. So I'm not going to present all of them because it would take too long, but just know that this is another contribution, because we're hoping that with these guidelines, with these additional design principles, it will help researchers conduct this type of research project in a more effective way. Now, I can't resist talking about one little project, which is called SPART, which is a sub-project of Si2Learn. It's my fourth PhD student's project, Sébastien Simon. And I don't know if you're familiar with interactive tabletops, so that's these huge tables that are great for collaboration. This has been studied in several research projects, but they're very bulky and very heavy, so there's no way you're going to bring an interactive table like this with you out on a field trip. And so Sebastian designed a low-cost and mobile interactive tabletop where you can basically use any map, put it down, and with the smartphone that's in your pocket, you can augment this map and make it interactive. So we're going to test this with students very soon. So now that I've talked to you about my two first research objectives, I would like to talk to you about a project that I have in the future, two projects actually I have for the future. And the objective here is to bridge the gap or reduce the gap between the research that is led in technology-enhanced learning and a society, meaning what is going on in our classes, currently in our classes, in our French schools right now. So this is kind of the current situation. We have researchers in TEL who do a great job. They create research prototypes that are co-designed with teachers. They test them in real context in schools, and for which we actually have scientific proof that they do work and they are useful for learning. But, well, that's it. They just stay up there in research, and they're never or hardly used in schools and by teachers, because teachers in schools mainly work with ed tech companies. So my objective is to try to think of a favorable ecosystem that could help these three actors work together. My idea is to propose this ecosystem around a federation of software forges. So a forge is like a GitLab where you can deposit your code. And I was thinking that this federation of forges could be especially useful if it hosts open source software, open source technology enhanced learning. So the objective here, the idea is that researchers will deposit the code of their prototype, their research prototype, into a forge, into an open source forge, that edtech companies can then take these prototypes, improve them, add functionalities, and put them back into the forge as open source software. Very important. Then we can have the teachers in the schools that can take this software for free and use it, install it in their schools or whatever, and contribute back to the forge by providing feedback, asking for new functionalities, for example. And in the case where they're using authoring tools, even provide the code, meaning that if they're using authoring tools, they're going to produce tell systems. And so these systems could be put back on the forge to be used by other teachers, for example, and therefore contribute to the community. So what I've been doing is trying to identify the different actors that could reinforce the links between these three actors. So here, links between researchers and schools, but most importantly, what's complicated with this model is to encourage edtech companies to work with researchers and produce open source technology enhanced learning systems, because this is just not what they usually do. It's not their usual business model. So the question is how to find financing, and this is a tricky question. So one of my contributions is the beginning of this, but it hasn't been published yet. It's just a beginning of contribution, this proposition of this ecosystem. And it's definitely something I'm going to work on in the future, because the two last projects I showed to you, so C2Learn and MixUp, I managed to identify two edtech companies that were willing to continue working with us. And now we're working on trying to find the financing, the business model that could allow these edtech companies to survive while providing a free access to these tools for teachers and schools. My second research project on this ecosystem is a GTNUM project that was just accepted a few weeks ago. And here the idea is to consolidate this part of the diagram. What we would like to do is help teachers, any type of teacher, put information, use forges and put information back on the forges. And I don't know if you're familiar with GitLab, for example, but it doesn't have an interface that's very user-friendly. It's kind of scary, actually, if you're not a computer scientist. And so the objective of this project is to improve the interface of software forges to help these teachers contribute to them. So as a conclusion, you've seen that I have two main research objectives. The first one is to provide methods, models, and tools to help all the necessary actors design effective technology-enhanced learning systems. And the second one is to provide adaptable models and authoring tools so that teachers can develop technology-enhanced learning systems themselves with the resources and the hardware that they already have in their classes or in their schools. So I've proposed a several number of contributions for both of these research objectives. The first one, through several projects, the first contribution is a set of design principles for using game mechanics, mobile learning, and innovative HCI for learning. This is definitely something I plan on continuing in the future. Based on our experience leading these projects, we were also able to propose a set of pragmatic implementations for the design-based research method to help researchers conduct this type of project. We also were able to identify guidelines and a training method to help teachers design their own innovative educational tools. And with PhD, I worked on creating a serious game catalog. For the second research objective, we also have 4 projects here. This helped us identify the advantages and the challenges of technology-enhanced learning authoring tools. We also proposed models and authoring tools for 2 specific type of technology-enhanced learning: mixed reality for education and mobile learning for field trips. And this is something that I will continue in the future with the 2 companies that I have identified, Ositis and Inode Solutions. And finally, we proposed design principles and guidelines for managing this type of project on authoring tools. Now, if we look at these on a timeline, you can see that since I've been at LUM, I've worked on 7 projects. I've led 7 projects, including one that's quite big because it was financed by the national agency, ANR, National Agency, Research Agency of France. I also participated in the Rêverie project. I've had 4 PhD, I've co-supervised 4 PhD students, 2 of which have already defended, and 2 who will defend very soon. In terms of new projects, I have the project with the Forge and the project with the JT NUM that have just started, and for which we have financing for a 5th PhD. I will also continue what I've started with the Mix-Up project on an Erasmus Plus project. I hope it will be accepted. I'm working on this with several colleagues, several researchers, European researchers. And we also agreed, we're also looking for a PhD candidate for a thèse CIFRE. This is a PhD that is financed by Inode Solutions, the company that has agreed working with us on Mix-Up. So this is great because we will be able to work with them for at least 3 more years on this project together. And I have a new project with a Canadian lab financed by VMware, and for which here we're going to be working on authoring tools for virtual reality simulations, which is something that doesn't exist yet, and for which we might have the possibility of having a 7th PhD. In terms of conference organization, I've been strongly implicated in the International Serious Games Society for the 5 or 6 past years now. I organized their international, international competition on serious games in 2018 and 2019. And in 2020, I organized the Games and Learning Alliance Conference with more than 500 attendees. I also organized this year in March the EdTech, an EdTech conference that was right here in Laval with more than 120 attendees. And what was interesting is that there was teachers, researchers, EdTech companies, and representatives of the Ministry of Education. In terms of keynotes, I was invited several times, mostly to talk about serious game design, but also authoring tools at the last, it was a summer school organized by the European Association of Technology Enhanced Learning. I thank you for your time. Thank you for listening to all this. And so this is the end. If you have any questions, I'll be very happy to answer them. And well, I'm not live here, so you can just send me an email. Bye, everyone.